So I have my conductor, and now I want to talk about that movement of charge. So that's called, we'll just call it current. Technically, it's the electric current. It's because, of course, water can have a current. Anything that moves, anything that flows is electric current, or is a current. In fact, you've never seen an electron. They're small, they're hard to see. But you can picture your electron current flowing as a visual, much like water flowing through a contained system. So a lot of people find that easier. Your text pulls a fair amount of imagery, and I'll try to pull it there too. But what's going on in electric current? Well, let me change that. I forgot the word I wanted to start with. The amount or quantity. Yeah. So we could measure the number of electrons that flow past a certain point in the conductor in some time. That's not a real practical number because we would have, billions and billions of electrons flowing by to have anything happen we can see. So what we're going to do instead is we're going to talk about it in terms of those coulombs, which is just a general measurement of that charge. Coulomb was a guy who did stuff in electricity in about 1800 or so this stuff after it. We won't use his specific unit a lot, but I'll just give it to you right now. Just mention it. So idea we measure current in. It is a unit you have all heard before, though you may not know what it actually means.
Amperage?
Yes, amps. We'll get technical, it's ampere. Let's pronounce it with a French flair. But I've never heard anybody say it that way. Amps. So, and by the way, you don't have to learn metric versus US customary because we actually use metric here. Electricity, all this stuff was figured out after that was said. So, yes. 1 amp, abbreviated amp, A, is equal to the flow of 1 coulomb of charge per second. We will almost never use coulombs per second. I'm going to give that to you now, so later on I can say, remember I told you that. But you will use amps. When we measure it in amps. Electric potential. I'm going to refer back now to a science term, physics term, potential energy, because it's, again, easier to visualize, even though I have to describe potential energy first. So we talk about gravitational potential energy if you take physics. And that's, if I have an object sitting this high, it has some potential energy based on that mass and how high it is above the ground. If I move it twice as high, it has twice as much potential energy. That means if it were to fall and strike the ground, it would strike with twice as much energy. Break things, hit things, impact, whatever. That's all mechanical energy. When we go to electricity, and the reason we end up with this is people took those same concepts and applied them to electricity because we defined mechanics here, and 150, 200 years later, we defined electrical values. So we just took that concept and went with it. It does mean now at times I have to go, by the way, this whole mechanical thing that you guys aren't Marines are not doing is why we call it that. But a lot of times they're a lot easier to visualize. So electric potential. This is related in the ability of charge to do work we might call the distance space, I don't know, one of those words. Electrically between 2 points. All right, so I just told you this whole potential energy, so much here, so much here. You have electrical potential energy, which would be if I take something and I separate charges by so much, the potential energy is going to be based on the total charges and how far apart they are. The closer they are together, actually, the more potential energy it has. The more they want to get together, because positive charges and negative charges are very strongly attracted. They would like to crash together. Holding them apart takes a lot of work. Releasing them allows a lot of work to be done. Electric potential isn't exactly potential energy, but it's kind of close over in that area. All right. The unit of measurement. This is another one you've heard before. In fact, you've probably heard it more than else. Go for it, you know now.
Volts.
Yes, volts. Again, Voltaire, if you'd like, but more than that pronounced. So, I don't know. We're just disrespectful to all those French names. Okay. The volt. So these are measuring two different things, but they're related. The volt is the amount of the ability to do something between 2 points. The two ends of a battery, or the two connections of a battery. We measure in volts, right? What's a standard like C or D battery or AA battery? Yeah, for voltage, you know, 4 volt. Close. They're 1.5 volts. In fact, they're all 1.5 volts. AA, AAA. Yeah, C's and D's, they all have 1.5 volts. So they can all provide exactly the same amount of distance between the two ends as far as their ability to do things. But what's the difference between like a AA and a D then? Yeah, the ability to provide those amps. Because what's going on inside of a battery? Well, you just have a chemical reacting in and it strips electrons off of one and moves the other. So you got a bunch of positive charge on one side, a bunch of negative charge on the other, 1.5 volts. You could ask the AA to do some things that it just can't do because it can't provide enough current, but the D would be able to do. So those two are related, but not the same concept. I can measure volts between two things when nothing's happening, like that battery's just sitting. So what's the volts on a 9-volt battery? 9 volts, yeah. See that. What's a car battery? 12 volts. Good. Actually, it was one semester I asked and nobody knew what a car battery was. But I mean, I guess there's no reason people don't get under the hood as much anymore. Yeah, so voltage just sits there. That battery stripping charges apart and stripping charges away from one end, moving them from electrode to electrode, and it just provides voltage, even though nothing is happening. It's just sitting there. So electric potential happens regardless of anything else going on. You can just have two things set, just like I could set that block or that ball up here. There's some potential energy just by being here. Electric current only happens when charge is flowing. Only when I make a connection and let charges flow. If I make a connection, then I have made something called a circuit. Specifically, electric circuit. So electric circuit, or any circuit actually, I mean by definition, I don't know if you recognize the root, but begins and ends at the same spot. Circuit, circus, circle, all the same words. All that. So, I don't. They all have the same root. But that means if I start at one point and I complete a circuit and have the ability to end up at the same spot. So if I take my battery here, positive and negative end, and I say have a light bulb over here. That's my light bulb. Two electrodes. I connect a wire here and I connect a wire there. Nothing happens. My battery might have 1.5 volts, but nothing's happening. Why? There's nowhere for current to flow. Current could flow through this conductor, but it has to go all the way back to where it started. So I need to take a wire on this side, connect it over. Now I have a circuit. Electric circuit has a beginning and end that's exactly the same spot. That's what we're going to do in lab this week. You're going to build your first circuits with a battery and a light bulb. They're going to look very rudimentary. A couple connections on the ends. And you're going to measure current and voltage. So we're going to learn to do that. Yeah.
Is it still considered a circuit if it's not connected to something like a light bulb?
If you just, all right.
There was just nothing there.
If there's nothing there and it was open, this is called an open circuit. So it's not really a circuit because it's not closed. Nowhere can current flow. That's what the light switch does here. We looked at the light switch. All they do is wrong. One direction to connect the two, so current flows through into the light bulbs. Connect the other way, just disconnects it, breaks the circuit. So no current flows. Basic switch does that. If you were to actually complete this, this is something we would call a short circuit. You've probably heard the term before, and it's considered bad. And it is. Because what you've done is connected the positive end of the battery directly to the negative end with nothing to regulate the current. So it's going to try to provide as much current as it possibly can. And what would actually happen if you did that is the battery will start warming up pretty quickly, providing less and less current. If you let it go long enough, it would get overexcited. Let acid and stuff out. Yeah.
It's just a fairly dumb question. But if you connect the positive of one battery to the negative of another, would it still be a short circuit? Or
Nope.
would it be open?
This has become less common now, but almost all flashlights, back when we had, didn't have LEDs, we put batteries like that, and inside the flashlight, you wouldn't have little pointing down wires, but you'd go off the bulb. Why? Why have?
Well, they're
1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. Because I'm going negative to positive, I'm adding those all up. So I actually get 6 volts total out of it. So that makes the light bulb brighter. So I don't know if you've ever seen those old lights. Like you see them, used to be a lot of them ones you see for police or something, because you also have 4 9 volts in the other end of the metal canister. So you can turn it around. It's a billy club. I say that, and it actually is. But you needed all these bulbs to light the light bulb up. We kind of got away from that because, well, we have LEDs now. You can power with a couple double A's. So yeah, this week in lab, my goal is to teach you to measure, use the equipment here to measure voltage and current, and you're going to build some circuits with the light bulb. So that's our goal this week. The homework, in fact, let me do this. I know some bunch you have to leave. Those that don't, stay around through the lab together. Do me a favor, grab one, pass those around to everybody. I did this the first day. Starting next week, you are in charge of your own printing. There is a printer across the hall. Do me a huge favor and do not show up to class at 10 and start printing. get here early and print it or print it after, I don't care. But I find it a little frustrating when I start lecture before like do it on your own time. But you have access from these computers are all general college computers, printers over there. Once again, a reminder from earlier, everything is on Blackboard. The entire semester is out there. If any of you would like to get ambitious and get ahead, and I decided this way partially, I have a few people who work full time and they'll want to come in and do like 3 or 4 weeks. They'll want to come in like a whole day. Well, I'm going to work 3 weeks of stuff on Tuesday and Thursday this week and be done. So I got to be out of town next week. You are welcome to do that. If you get behind, I'm not going to kick you out, but you know, there's a reckoning at the end. You run out of time at the end. We have a lot. We have an exam, I think, in week 7, so look ahead to that. So it'll cover everything. But otherwise, it's 5 till. I know some of you have to go somewhere. Those of you who do not need to go anywhere, I will show you how to do the lab.